Question number 11. We have a child who is running up a set of stairs 4 times. The times are recorded. Those are 10 seconds, 20 seconds, 30 seconds, and 40 seconds. So this is the time he takes. These are the times he takes to run up the stairs. Now something that should come to you immediately, that is that the energy spent by the child is the same throughout the 4 times. It is mgh, and it is the work done against gravity. E here is constant for all the 4 times. The formula for power is equal to E by T. So according to the formula, if we try to calculate how much power he has, what is his useful power output when he travels up, it will be E by T, which is E, which is constant here, divided by 10 for this case, E by 20 for this case, E by 30 for this case, and E by 40 for this case. Now these are the power outputs for the 4 options. Out of these we have to select which is the largest, and we can see that this option A, is the largest immediately because it has a smaller denominator. The smaller the denominator in a fraction, the larger the fraction is. Therefore A is our correct answer. Question 12. We have 4 diagrams that show 4 different shoe sizes as seen from underneath. Which heel is most likely to cause damage to the wooden floor? Let's take example from a diagram. Okay, let's say this over here is the shoe. The first option's heel looks something like this. So the area it covers is like this. Comparatively, the second option, let's say the shoe looks like this. The area the second heel, the last heel covers is this big. The only difference between the options is the area, the surface area of the heel. Now you can see over here that this area is greater compared to this area. Small, great. Now, when we talk about damage, we should be talking about pressure over here. The force applied by all the 4 heels is the same on the ground because the same person is wearing them. Force will be equal to m into g as long as the mass is same, the same person is wearing these shoes, then the force applied by the person on the wooden floors will be the same. The formula for pressure is force divided by area. So over here, option A has the smallest area, option B has a larger area, option C has an even larger area, and option D has an even larger area. Therefore, the pressure applied by option A will be the largest because it will make for the smallest denominator, just like the previous case. Therefore, the correct answer is option A because pressure is indirectly proportional to area. Because pressure is indirectly proportional to area, the smaller the area is, the higher the pressure, and therefore we have more chances of damaging the wooden floor. On to question number 13. We have been shown an instrument which looks like this. This is a fairly straightforward question, and this is something you will have to remember. Now there's a liquid inside this instrument like this, and the level of the liquid is same. This instrument is used to measure the pressure inside a container, and it is called a manometer. Therefore the answer is C. You'll have to remember that this instrument is called a manometer. Moving on to question 14. We have been told that water exists in 3 states: solid, liquid, and gas. So ice, liquid water, and steam, which is basically gaseous water. In which states or state Is the motion of molecules only vibrational? Okay, so there's something fundamental about states, solid, liquid, and gas. The point is that inside a solid, molecules are packed very tightly, very tightly. So, like they are touching each other and they cannot actually move. The only thing they can do is vibrate. So, there's no motion for solids and there is vibration. For liquids, the molecules are a bit apart, so maybe like this. They still touch, but they are apart so that they can also flow. That is something you must have learned. In liquids, the molecules can flow, so there is motion. There is less motion, but there is motion. There is also vibration. In gases, obviously the molecules vibrate. The molecules always vibrate, but they are so far apart that the motion is very high. So there is vibration and there is also motion. Out of these three cases, solid, liquid, and gas, the only case where there is only vibration is the solid, and ice is the only solid. Out of our three options, ice, water, and steam, therefore option A is correct. Question 15. Which statement about evaporation is correct? Okay, we'll have to evaluate each of the statements. A says evaporation causes heating of liquid. Let's think about a diagram. Let's say this is a beaker, there's water inside it. And we know that evaporation only happens through the surface, so we'll talk about that. Okay, so when evaporation happens, what happens is that this molecule over here at the top actually takes up heat from its surrounding. So it will take heat from its surrounding molecules and it will flow away. It will become gaseous, it will have more energy and it will flow with the air. Now, as it is taking heat from the surroundings, it is actually cooling the surroundings. And option A talks about evaporation causes heating of the liquid, which is absolutely wrong because this molecule is actually cooling the liquid. So option A is definitely wrong. Option B, evaporation only happens from liquids. Okay. Now this option seems like a very promising option because when we have a solid, there is no evaporation. There is no movement, there is no evaporation, and therefore solids don't evaporate. When we have gases, gases are already at gaseous state. Evaporation literally means going from liquids to gaseous state. Therefore, in gases too, there is no evaporation. We only have evaporation in liquids. Molecules are a little apart, they are free to move, and therefore, air molecules take advantage of them and take them away. Therefore, B seems like the most promising option. Let's star it. Option C says molecules escape from anywhere in the liquid. This again is false. So let's say we have a molecule here and one molecule here. The reason for evaporation is that wind flows and it takes the molecules away. So it gives them energy and it takes the molecules away. This molecule over here does not have any access to any kind of wind. Therefore, this cannot evaporate. So option C is also wrong because molecules can only evaporate from the surface of the liquid. So this is also wrong. Option D says only the least energetic molecules escape. This again is just the reverse of what actually happens. In reality, the molecules at the top over here have the highest amount of energy, and because of wind, they gain even more energy and they also take heat. So, in reality, actually, the higher energetic molecules escape and the least energetic ones stay behind. Therefore, this option is also wrong. So, B is correct. Question number 16. We have a setup that looks something like this. We have a laboratory table. The temperature of the laboratory is 20 degrees Celsius. Maybe it's in a cold country. Now, there's a piece of melting ice over here which is currently at 0 degrees Celsius, and we have a Bunsen burner over here. This is a Bunsen burner, and we have boiling water above it. So the temperature of the boiling water is 100 degrees Celsius. For ice, it's 0 degrees Celsius. We have to tell if left alone, will the temperature of this water increase or stay constant, and what will happen to the temperature of ice. Let's think about the water first. Let's think about the case if it can increase or not. Okay, we know something about water, that water cannot go above 100 degrees Celsius. Water boils at 100 degrees Celsius. We can find steam at 1000 degrees Celsius, at 2000 degrees Celsius, but water cannot go above 100 degrees Celsius. If we try to make it go above 100 degrees Celsius, then it gets converted into steam. What is happening here? So the temperature cannot increase definitely. Can it decrease? If we were not boiling the water, it would have tried to reach 20 degrees Celsius over a long period of time. But we are boiling it over here. We are constraining the water from decreasing its temperature. So it cannot decrease its temperature at all. Therefore, it will remain constant. Now let's think about ice. Can the temperature of ice decrease? We are not cooling the ice. No one is cooling the ice. In fact, the room is at 20 degrees Celsius. So it is obvious that ice will not cool itself. So this is not a possible option. Is it increasing? Well, kind of, but not really. Ice will try to go to 20 degrees Celsius, but it cannot as ice. It will melt itself to water, but it will get converted from ice to water at 0 degrees Celsius. Therefore, ice is not increasing its temperature either. It is staying at 0 degrees Celsius and getting converted to water. So, it's also constant at 0 degrees Celsius, and boiling water is constant at 100 degrees Celsius. Therefore, the option A is correct. Question 17. We have to calibrate a liquid and glass thermometer according to the Celsius scale, and we have to tell which one of the options can be a fixed point. Now, what is a fixed point? A fixed point on a thermometer scale is some value, some point in temperature on that scale, which can be easily reproduced. So the best example we have for Celsius scale is the boiling point of water and the freezing point of water. Because everywhere on earth, wherever we have one atmospheric pressure, which does not vary a lot at any place near sea level, we will have boiling water always at 100 degrees Celsius, and the water will always freeze at 0 degrees Celsius. So what this means is that you can assure that if you're boiling water and you dip a thermometer, an already calibrated thermometer inside it, you will get the value 100 degrees Celsius. This is what a fixed point means. Now let's check through the options. A mixture of water and ice. This seems like a very promising option because a mixture of water and ice will always be at the freezing point. It will always be at 0 degrees Celsius because ice will try to melt, and it will melt at 0 degrees Celsius, and water will cool due to ice. So it will also be at 0 degrees Celsius. This is a promising option. Option B says in a hot drink. When we say a hot drink, we don't know what the temperature of that hot drink it is. It might be 40 degrees Celsius, it might be 70 degrees Celsius, which does not actually give us a lot of room to fix it. It is not a fixed point. So option B is wrong. Option C says in a Bunsen burner flame. Yet again, we don't know the exact temperature of that Bunsen burner flame, therefore, it is not something which we can use. And also, probably a Bunsen burner flame is very high for a liquid and glass thermometer. For some of them, in a refrigerator. Now, yet again, inside a refrigerator, there are different zones where the temperature can be different for each zone. Therefore, this again is a wrong option. At one point, it may be minus 8 degrees Celsius, and in at some other point, it may be 0 degrees Celsius inside a refrigerator. So, D is also wrong. Therefore, A is the only correct option we have. Question number 18. We have a room. So let's say this is one of the walls of the room, and we have attached aluminium foil to the room in a cold country. Okay, so let's say this is the aluminium foil. It is attached throughout, but I'm just drawing a section of it. Okay, and we have to tell which of the methods of thermal energy transfer are reduced by the foil. So let's talk about the methods first. So one of the methods is conduction. Another is convection, and the last one is radiation. Now, conduction can only happen through solids. Liquids too, but it's very low. Let's also count liquids, but it's very low. Now, for convection, we have liquids and gases, and collectively we call them fluids. For radiation, well, radiation can actually happen through everything, even solids, like some part, a little bit. It can even happen through vacuum, and this is a speciality of radiation. And radiation happens using IR rays. The medium for convection is flowing of fluids. So fluids flow. And for conduction, it's vibration. So conduction is due to vibration of molecules throughout. So maybe one of the molecules over here will jiggle, it will make the next molecule over here jiggle, and that will pass on, and that is how heat is transferred. Okay, let's think about conduction first. So as soon as the aluminium foil starts jiggling, as soon as it gets hot, it will make the wall jiggle, and therefore conduction, there is no stopping conduction. The aluminium foil will allow conduction anyways, therefore conduction is wrong. So aluminium foil will not reduce conduction. Now let's think about convection here. Okay, convection. So we have some air over here maybe, and it is flowing like this. Convection happens through fluids and due to a flow. So let's say this is our wall again, and we have a window. Now, if we have a window, it is very obvious that we will not have aluminum foil on the window. Therefore, the air can go out and also come in. So convection won't be stopped like that. And let's compare it with the case that we didn't have the aluminum foil. If we didn't have the aluminum foil, then again, convection cannot transfer heat. Convection cannot transfer heat through a solid wall because it only happens through fluids due to the flow of fluids as stated here. Therefore, convection is not reduced. It was already very low. It was already through only the windows. So convection is the wrong option because it is not reduced by the aluminium foil. Now let's talk about radiation. I feel like radiation will be reduced because we have IR rays over here. Now, as soon as the rays hit the aluminium foil, they will bounce back. That is what aluminium foil does. Aluminium foil is shiny and therefore it will bounce back the rays. Aluminium foil will bounce back the rays, and only a part of heat will be absorbed here. The rest of heat will come back inside the room. Therefore, radiation will be reduced, heat loss by the radiation. So I think D is our only correct option, only possible option. Question 19. There's a boy who is riding his bicycle, and on a very cold day, he puts one of his hands on the metal handlebars and the other on the rubber grip. So we have the metal handlebar here and the rubber grip over here. Now, there's something special about metals. Metals are a better conductor of heat. This can also be demonstrated through a spoon. When you touch a metal spoon, what happens is that the energy is instantly transferred to your hands because the metal in the spoon is a great conductor of heat. Therefore, it instantly transfers the energy to your fingers. Now, your fingers are at a higher temperature. The metal is at a lower temperature. Therefore, you feel that the metal is cold. Instead, when we talk about rubber, rubber is not such a great conductor of heat, therefore, it will not transfer the heat to your fingers. Therefore, your fingers and rubber remain at the same temperature, so you don't feel that the rubber is cold. So the main reason for metals feeling cold is that metals are a better conductor of heat. Let's check the options. A. The metal has a higher melting point than rubber. We don't care about the melting point, so option A is clearly wrong. Option B. The metal has a lower thermal capacity than rubber. This again is wrong. We don't care about the thermal capacity either, we care about which is a better conductor. Option C says the metal is a better thermal conductor than rubber. Option C is our correct option because it is talking about conduction and which is a better conductor. Question 20. Wow, we are at question 20. There's a box which contains four types of waves: gamma rays, sound, ultraviolet rays, and X rays. So there's gamma, there's sound, there's ultraviolet, which I'll just use UV, and there's X rays. Now we have been asked how many waves in this list are transverse waves. Okay, for gamma radiation, we know that it is a form of electromagnetic waves which are transverse. So this over here is a transverse wave. Sound is a longitudinal wave because it has rarefactions and compressions. So sound is a longitudinal wave. UV is also a form of electromagnetic radiation, therefore it is also a transverse wave, and X-rays are also a form of electromagnetic radiation, therefore they are also transverse waves. So we have three transverse waves, and therefore the option that is correct is C.